So we left off that the negative exponent on C is going to make me flip the fraction 27 over 8, and I'm going to do 2/3 on each, positive 2/3. Now, the 2/3, what that means is I'm going to do the cube root of 27, and whatever I get, I'm going to do it to the second power. That's what the 2/3 get split. At the bottom, I'm going to do the same. I'm going to do the cube root of 8, and whatever I get, I'm going to do it to the second power. Now, the cube root of 27 is 3. So I have 3 squared, better known as 9. The cube root of 8 is 2. 2 squared, better known as 4. Now here, write each as a radical. Two ways how we can do this. Let me start with example B. 3/4, I can do the exponent first. I can do 6 to the third, and I can do the fourth root later. So I can do the exponent first, or if I want to do the root first, I'm going to say the fourth root of 6, and whatever I get is to the third. You will be asked specifically for which one. Now, if it says do the root first, that's my second example. If it says do the exponent first, that's the first example. Now here, for example A, I can say the second root of 13 all to the 1, which we know that when we do a square root, that's already base 2, and then exponent to the 1, we don't have to write. So I'm just going to call that radical 13. Now in example C, the 5 over 8 only has to deal with the m, not the 9. If I wanted it to deal with the 9, I would have put the 9 and the m both inside parentheses. Now I'm going to do this as the 8th root of m to the 5th, and then the 9. Now you guys say, well, what? Can I do the 8th root of m all to the 5th and write the 9? That's the exact same thing. Mathematically speaking, they're both the same thing. Looking at D, the 2/3, it only has to deal with the x. So I can do the cube root of x squared and my 6 on the front. Now, because of the negative on E, I'm going to write that as 1 over r 2/3. So I have 1 over the cube root of r squared. For example F, I have the square root of a squared plus b squared, and then to the 1. So 1/2 can only be written as just the square root. Now here, write each radical as an exponential and simplify. Technically here I have 10 to the 1, and my square root is root 2. So I'm just going to write that as 10 to the 1/2. There's nothing else I can do, so just 10 to the 1/2. Looking at example B, I'm going to write that as 3 to the 8 over 4. But 8 over 4 can be simplified, so I'm going to write that as 3 squared. And then 3 squared can still be simplified. I'm going to call that 9. Now in example C, I have z to the 6 over 6. Now my fraction can be simplified as z to the 1, better known as z. When we have the same base, all we do is copy the base and add the exponents. In multiplication, we add the exponents. 1/2 plus 1/4. When we're dealing with fractions, we must have a common denominator. So 1/2, I'm going to write that as 2 over 4. The other one is 1 over 4. Now I have a common denominator. I'm going to add the exponents. So I'm going to have 3/4. So it's 2 to the 3/4. When we're dealing with division, example B, and it's the same base, I'm just going to copy the base And I'm going to subtract the exponents starting from the top. So 2/3 minus 7 over 3. So that gives me a negative 5 over 3. Because of the negative sign, I'm going to say 1 over 5, and my 5 is 5/3. Now, when we have parentheses, get rid of parentheses by multiplying the exponent on the outside to the exponents on the inside. So here I have 4 times 1/2. That gives me x to the second. Now on the y, 2/3 times 4, that gives me 8 over 3 over y. Now the y at the bottom is y to the 1, but since I'm going to subtract my exponents on the y's, I'm going to write this as 3 over 3, just so I have the common denominator. So when it comes to x, I just have an x squared on top. When it comes to y's, 8 over 3 minus 3 over 3, that gives me y to the 5 over 3. There's nothing at the bottom, so there's no more fractions. Now looking at example D, let me get rid of parentheses by multiplying the exponent on the outside to the exponents on the inside. So I have x to the negative 8 over 3. Y to the positive 12 over 3 over x to the positive 4 over 3, and then y to the negative 2 over 9. Remember, I'm multiplying my exponents. Now, let me deal with the negative exponents. X has a negative exponent on top, so I'm going to bring it to the bottom as x to the positive 8 over 3. The negative exponent on the y, I'm going to bring it to the top as y positive 2 over 9. So let's combine the exponents on the top. I'm going to add them. But before I look at 12 over 3, my first exponent, 12 over 3, I can write that as 4. I can simplify that exponent. But now I want this to be common denominator. So 4, I can write that as 36 over 9. So when I combine my like terms, when I add my exponents on the top, I'm going to have y to the 38 over 9. At the bottom, I have x to the 12 over 3. Now 12 over 3 can be simplified. Instead of 12 over 3, I'm just going to call that 4. Now here, the roots are not the same. The base and the inside is also different. So what I'm going to do, I'm going to write them as exponent, as fractions. So the first one, I'm going to write this as x to the 2/3 times x to the 1/4. It's the same base x, so I'm going to add the exponents. Now 2/3, let me rewrite that as, I want the common denominator. So on the first one, let me multiply top and bottom by 4. So I have 8 over 12. On the second one, let me multiply top and bottom by 3. I have 3 over 12. Now that I have a common denominator, I'm going to add them. So I have x to the 11 over 12. Same thing with example B. To begin with, I have x to the 3 over 2 over x to the 2 over 3. Let me rewrite them as common denominator. The first one, let me multiplied everything by 3. I have 9 over 6. Second one, let me multiply everything by 2. 4 over 6. Let me subtract my exponents, and I have x to the 5 over 6.